Hello everyone, so we're group 3 and we're going to be introducing IEEE 802.11 Wi-Fi. My name is Steve Menas.
I'm Arturo Chacon.
My name is Allison Sanchez.
So Wi-Fi, or wireless fidelity, became the standard for the 802.11 for wireless local area networks. And the way it is that radio frequencies are able to transmit data through the air, through a device to a modem or router that will be connected to the internet. And that access point will act as a base station, if you will. It first started in 1997 when it was the 802.11 that later became upgraded to B that have been implemented in some devices already. Following on, there were multiple upgrades. Now in the figure below, you'll see that C through F, H, and I are pretty much minor upgrades for these services, whereas the other letters serve as major upgrades in terms of bandwidth, transmission speeds, and ranges.
So how does Wi-Fi work? So a Wi-Fi hotspot is created by installing an access point to an internet connection. A device that has Wi-Fi can then connect to that network wirelessly. A computer adapter translates data into radio signals, which can then be received through a wireless router, which decodes the data.
So again, we began our story of Wi-Fi with the 802.11. Through this, we have protection in terms of passwords that allow characters, numbers, and special characters as well, and increased bandwidth, transmission, and range for the router. One key thing about these routers is that they have a unique feature being backwards compatible, meaning that no matter what new generation of Wi-Fi comes out, you're guaranteed to have your older generation device to be connected to that. However, no matter how advanced these Wi-Fi routers can be, their speeds are limited by the wire connections to them, and as well as their reliability. And today we find Wi-Fi in laptops, even to our refrigerators. So here we have a timeline that spans from 1999 to the future, beginning with 802.11b. In 2004, we find our first major application of Wi-Fi being PDAs, cell phones, TV, and the introduction of the G. In 2007, there is an increased demand for Wi-Fi integration, and a major portion of all the data used is contributed to gaming, videos, music, and just traditional internet surfing. In 2011, thousands of hotspots are found in all continents with millions of private users. And in 2015, there are over 4 billion Wi-Fi devices. And we are heading towards using the multi-user, multi-input, multi-output. And in the future, we're looking to have billions more devices in the next few years with a huge influx of global traffic, and hopefully our connection speeds will not just increase but also be reliable.
So current disadvantages and advantages of Wi-Fi would be The advantages being freedom to work in any location as long as there is signal. It's very flexible in the sense that there is no cable required, so mobility is really simple, and it allows mobile access through the network itself. The disadvantages, however, is that it is slower than having a cable, and the range does affect the potency of the data transmitted. It travels best through open space, meaning there can't be too many walls, even like water or glass that obscures the data. And the security isn't too reliable, as there can be unauthorized access or even denying of service. Today's wireless networks are able to provide a fast and reliable wireless access to the internet for things like browsing the web, exchanging files, or watching audio/video streams. However, this has created a new problem in the sense that there are too many people using the internet now, as well as applications that require the internet. So now we have a high demand for mobile-rich media content, mainly motivated by the use of smartphones, tablets, and other multimedia portable devices. And alongside this, there are now many applications on very obscure items, such as ranging from low power sensor nodes to connected cars.
So, what does the future look like for Wi-Fi? Craig Partridge, a former editor-in-chief of the Institute of Electronics Engineers, which is known as IEEE, Network Magazine, and a member of the first Internet Engineering Steering Group, stated in an article that by about 2020, software radios will have become the standard technology for commercial and military radios, employed in a range of devices ranging from battery-powered sensors and handheld devices to plugged-in devices, such as base stations. IEEE is working on a new Wi-Fi, which is called 802.11ax. This is going to be called the Orthogonal Frequency Division Multiple Access. This technique will allow multiple devices to share the same access point and the same Wi-Fi channel at the same time, which is something that previous generation Wi-Fis do not allow. Current innovation that is also going on that may have an impact on wireless networks is intent-based networking, which is basically a broad term that describes an increase in programmability, automation, and even machine learning capabilities that can be applied to wireless networks. So what are the elements of Wi-Fi? The access point is Wi-Fi LAN radio transceiver or base station that can connect to one or many wireless devices simultaneously to the internet. Wi-Fi cards accept Wi-Fi signal and relay information, so it can be internal or external. Safeguards are firewalls or antivirus protections that basically fight off unwanted users and keep information secure.
So these are references. Please take a look at the slide in case you have any questions as to where we attained this information. Thank you for watching our little lesson.